Welcome to the Hydraulic Press channel. Today I have excellent video idea. This is by far the best one that I have in long time. The idea is pretty simple as usual. What happens if you try to push rod into the steel tube that is too large? Because this from here down, this is about 65 millimeters. And then the hole here is 63 millimeters. So we are missing 2 millimeters. So, and I have like smaller here on the start, so I can like get this going. So what's going to happen when we push from here? I think it's going to go down, and this is going to stretch by 2 millimeters. But how far we can take this? If this is 10 millimeters too large, and that's the thing that we are going to today find out. I have here under the part I have force sensor, so we are going to first test this, see how hard it's going to be, and then I'm going to decide what's going to be the next step. I think we can like, and yeah, by the way, the thickness of the pipe is 5 millimeters, so it's pretty sturdy pipe, and I'm pretty sure that we can make this stretch a lot. But let's see first this. And the pipe is regular structural steel or mild steel or something like that. So when it's too much and it doesn't want to stretch anymore, it's going to just like rip and tear, not going to explode. But to be sure, I'm behind the safety blast shield thing, so if it explodes, I'm okay. But it's not going to explode. Maybe. Okay, here we go. Stretching 2 millimeters. I'm going to say that it's going to take 10 tons. Hey, pretty good guess. I think I'm going to leave it here. Okay, and one thing to note, that we made a mistake here. We went in dry. It would have been probably easier to have some lubrication between the two things. Is it? It doesn't get super hot, maybe like 20 degrees more. I'm going to say that that was 2 millimeters. Let's go 5 next. Yeah, 5 is good next step. And then we add some lubrication also. Okay, round 2. And now we have 68 millimeter diameter rod and 63 millimeter pipe. And I made these shorter. I was a bit scared that they're going to flip out or something. So now things are even safer, and to make it a bit easier, I'm going to add some lubrication here. Yeah, that's really good, like that. This goes here. Yes. Yeah, now it looks much more reasonable. I was a bit scared on the last go. Okay, and I'm going to say with the lubrication, it's going to be now 20 tons. Oh, that's a huge difference. It's less force. Yeah, the lubrication, that really makes the difference. Much easier. And I would say the temperature is also pretty similar. Makes sense because we did similar amount of work. And now you can see that it's like flaking away. It's not ripping at all. I say that how much we should go? Really hard to say. Let's go 5. Is 10 too much? Let's go 10. Yeah, let's go 10. Okay, now we have again 63 millimeter inner diameter pipe and 73 millimeter rod. And now I'm going to mount this here so we can enjoy the longer length without fear of it buckling or flying out from the press. Twice the stretching than on the last time. I'm going to say that 4 times the force, 40 tons. No, that's a bit too much, 30. And here we go. Okay, this is pushing it. That's a lot. Feel it really stretch. It just goes. That's penny tons. Now it's much hotter. Much hotter. Okay, this is quite like material intense thing to do because this is not coming out anymore. Of course I could cut it with the saw or something, but I cannot make the tools any larger, so I have to every time make a new tool. And I think we have to go bigger. It's not enough. I'm not sure it's going to rip ever. That's also one thing. Just, it has to rip on some point. Okay, time to end this. I think this is 120 millimeters diameter there, and this goes here, and I'm pretty sure that this is not going to spread all the way here, so something is going to go wrong on some point, and we are here to see it. It was quite a lot of work to do that tool, and this is like really slow video to make, but I think this I'm really hyped up to see this. Worth of the effort. And here we go. I was already worried that it's not going to happen. Okay, that's pretty interesting. Check this. The whole thing opened up. I think I want to try this one more time. There is probably some kind of seam on the pipe. I think it's welded pipe. And I'm going to turn it towards the camera next time. One more. I want to see how it opens. I'm not sure is there any seams on the pipe. Is it welded or somehow? I don't know how they make steel pipe. But if there is a seam, I think it's now towards the camera. It's really hard to say, it's so rusty. Come on! No! Yeah, again on the wrong side. I think there isn't much to see there, it just opens. Yeah, but hey, if you wanna see part 2 with thicker pipes, please let me know. It's going to be a lot of work. And I think with the thicker pipe, it's going to be more about how many millimeters we can stretch it before the force comes too large. And this is actually pretty close to the typical use of the press here, because we quite often press fit things with this. And when you are press fitting items, it's usually like 0.2 or 3 millimeters too tight. So it's completely different like ballpark than what we tried here today. Even the first one that was super easy, it was like 10 times tighter than it should be. Yeah, but that is all for today. Thank you for watching and have a nice day.